An organizational adaptation simulator for peer-to-peer. The real demonstration will be performed on a desktop computer running a fully operational simulator with the help of a poster to explain some underlying concepts. This video shows some screenshots of the implemented simulator and some slides about the concepts presented in the poster. Our target is to design organizational adaptation mechanisms for organizational-centered multi-agent systems. In particular, we are using a peer-to-peer scenario as a case study to apply our approach. Thus, we built a simulator to fairly compare different approaches with identical initial conditions. We call our approach Two-Level Assisted Multi-Agent System Architecture, or TOLAMA. We consider a domain level where agents perform domain-specific activities. In current scenario, these agents share some data among them. Agents are organized according to a certain social structure, protocols, and norms related to some global goal. On top of them, we add a meta-level set of agents in charge of updating previous organization to help domain level to achieve the goals. In the peer-to-peer scenario, domain-level agents played the role peer, and meta-level agents played the role assistant. In our approach, each assistant is in charge of a cluster of peers. They are grouped according to its internet service provider. Also, there are two norms, one limiting the number of simultaneous served peers, and another one limiting the bandwidth used by peers. The meta-level updates those norms to pursue the peer-to-peer goal, which is sharing data using the minimum time and network resource. Let's see the architecture of our simulator. It has three main components, developed over Repast Symfony. It has a specialized graphical user interface that offers different tools to control and analyze the evolution of the system. It also has an agent simulation component that makes it easy to implement an organizational-centered multi-agent system. And finally, it has a network simulation component to define the net topology and to simulate message transport during the execution. Thus, our simulator let us compare different adaptation approaches in a peer-to-peer scenario, like updating social structure, protocols, norms. We use it to compare different alternatives within our TOLAMA approach, such as using heuristics or machine learning to decide how to adapt the organization. Additionally, we use it to compare the standard BitTorrent peer-to-peer protocol to our organizational self-adaptation approach. We are going to see the execution of our approach inside the simulator. When we open the simulator, the graphical user interface displays the main layout. It shows how agents exchange messages among them. Agents have different colors depending on their role and status. For instance, domain-level agents, which play the role peer, are in blue color, but the ones having the datum are in green color instead. On the other hand, meta-level agents, which play the role assistant, appear in red color. When two agents exchange a message, a line appears among them. Let's see some further details using some screenshots. We can choose different parameters, such as the adaptation method or the network topology. During the simulation, we see how peers interact to obtain the datum. Meanwhile, assistants gather local information about systems evolution. At certain intervals, assistants agree to adapt domains levels organization, reasoning at an upper level than peers. They agree to update the norm that limits the number of served peers and inform their cluster. This adaptation alters domains levels activity, since some agents may have to modify their behavior to avoid violating the new norm. For instance, as the new limit is 2 instead of 3 in this screenshot, the serving peer stops sending data to one of the current 3 receivers. If we let it run, the domain level continues performing its activity, while at certain intervals the meta level updates its norms. In addition to the main layout, there is a resume layout that shows the path followed by data. We use this summary to compare different approaches. The simulator also offers some metrics to compare approaches, such as time consumed or network resource required. It offers more tools, like runtime plots, detailed logs, or offline plots generated from logs to compare different executions. We plan to extend our simulator and tool-AMA model with open mass issues, for example, agents that enter or leave the system, and agents that may violate norms. We have seen our approach to self-adaptation in organizational-centered multi-agent systems. Our simulator's architecture to test alternatives with identical initial conditions, and its implementation, which includes analytic and comparison tools. Thanks for your attention.